Hello, and welcome to today's video on fractional and negative powers. So, as you may recall at the end of my last video, we looked at the three power laws, which I have written out again here. And if you're unsure of what any of these are, please do see my last video on powers and roots. So, before we get into fractional and negative powers, let's start with a quick recap of what a power is. We have something like 2 to the 4, we know that that just means 2 times itself 4 times. Like so, in this case 2 to the 4 is 16. What this means is that if we have something to the power of 1, like 2 to the 1, that is just a 2 multiplied once with nothing else. So 2 to the 1 equals 2, and that's true for any number. So if we have 3 to the 1, that equals 3. 5 to the 1, that's a horrible 5, equals 5. 7,408 to the 1 is just 7,408. So anything to the power of 1 is just itself. Now, what about something like 2 to the 0? What is 2 to the 0? We have absolutely no idea. At the moment, we can't multiply something 0 times, but we do actually have a way of working it out using these three power laws, or more specifically, this first one, the top one. We know that 2 to the 0, I really can't write 2's today, 2 to the 0 times 2 to the 1 equals 2 to the 0 plus 1 power. That is our first law. If we go back and look at that, we've got ATM times a to the n equals ATM plus n. In this case, a is 2, m is 0, and n is 1. And obviously 0 plus 1 is 1. So we get that this is equal to 2 to the 1, which we know to be 2. So we've got 2 to the 0 times 2 equals 2. If we divide both sides by 2, we get 2 to the 0 equals 1. So we know that 2 to the 0 equals 1, and if we wanted to, we could do exactly the same thing to prove that any number to the power of 0 equals 1. For example, 3 to the 0 times 3 to the 1 equals 3 to the 1. Therefore, 3 to the 0 equals 1. So if we have any number to the power of 0, that equals 1, and any number to the power of 1 equals itself. And we'll be using these to look at negative and fractional powers. So let's start with negative powers because they're slightly easier. Say we wanted to consider something like 5 to the minus 1. Well, again, we know that 5 to the minus 1 times 5 to the 1 equals 5 to the power of minus 1 plus 1, which equals 5 to the 0, and as we've just seen, that equals 1. So we then get that 5 to the minus 1 times 5 equals 1, and again, if we divide by 5, you can do this, by the way. You can, if you have an equation, you can add the same thing to both sides of the equal sign, subtract the same thing, multiply the same thing, divide by the same thing. This is the very basics of algebra, which I will cover in a later video. So you then get 5 to the minus 1, obviously times 5 divided by 5 has no effect, equals 1 divided by 5, or just 5 to the minus 1 equals a fifth. So we now have, and again we could have done this for any number, so if we have a to the minus 1, that will always equal 1 over a. So 7 to the minus 1 is 1 over 7, and 943 to the minus 1 is 1 over 943. So what about larger, or well, technically smaller, but negative numbers of a greater magnitude, like say 3 to the minus 2? And we could do exactly the same thing. As long as you use the rules of power, you can prove, in this case, I'm going to multiply by 3 squared, because then we get that the powers effectively cancel and we get 3 to the 0 as our sum, or our product, sorry, which is just 1. So we get that 3 to the minus 2 times 9 equals 1. And then again, dividing through by 9, we get 3 to the minus 2 equals 1 over 9, which equals 1 over 3 squared. And the general rule is if you have some number a to the power of negative n, that equals 1 over a to the n. And that is how you do negative powers. So, obviously, now it's your turn. Very quickly switch colour. Work out the values of 7 to the minus 2, 5 to the minus 3, and 2 to the minus 4. If you want to pause the video to give yourself more time, then go ahead. Once you've done that, you should find that the answers are 7 to the minus 2 is 1 over 7 squared, which is 1 over 49. 5 to the minus 3 is 1 over 5 cubed, which is 1 over 125. And 2 to the minus 4 is 1 over 2 to the 4. And as we saw earlier, that 2 to the 4 is 16, so it's 1 over 16. Okay, now we go on to fractional powers. Let's say, again, let's take the number 4 and say we wanted to work out what 4 to the half was. Now, we can again use that first rule. In this case, we'd want to multiply by another 4 to the half. We would get that equaling obviously 4 to the half plus a half, which is just 4 to the 1, which equals 4. Great, but we still don't know what 4 to the half is. So what we can do is use our third rule of power, which, as you may remember, was a to the m to the n equals a to the m times n. So, for example, 2 cubed to the 4th power would equal 2 to the 12th, which equals... God. I'm sorry, I can't write a 4 today. 4,096. In this case, we've got 4 to the half. Now we square that. We're going to get 4 to the half times 2, which is 4 to the 1. So we know that 4 to the half squared equals 4. And let's just take the square root of both sides. We get 4 to the half equals square root of 4. In this case, that equals 2. So in general, if you have a to the half, your result will be the square root of a. You can check that again. If we did 3 to the half squared, we'd get 3 to the 1 equals 3, and then taking the square root of both sides, because again, as long as you do the same thing to both sides of your equals sign, the sum is, or the equality still holds. So again, yeah, so if you did 3 to the half squared, that obviously equals 3 to the half times 2, which equals 3 to the 1, which just equals 3. So you've got 3 to the half squared equals 3, and square root both sides gets you 3 to the half equals the square root of 3. See, we can't work out the square root of 3. It's about 1.7-ish, but you would normally just leave it with the root sign in. That's surds. That will be in my next video. So going beyond halves to any fraction, let's take a third quickly. So if I wanted to work out, let's go with, let's stick with 2. Why not? 2 to the third. Again, this time I'd raise it to the third power to get 2 to the third times 3. So whatever to show what this equals to, I basically just want to get that fraction into a power of 1 because it makes the maths a lot easier. That obviously then becomes 2 to the 1, which we know equals 2. So 2 to the third cubed equals 2. And then, as we see, we can take the cube root of both sides. That will cancel with the cubed effectively. So we know that 2 to the third equals the cube root of 2. And there we've got the cube root symbol, which I introduced last lesson. So finally, what if we have a fraction that doesn't have a 1 as the numerator? So something like, let's take 5 to the 2/3. Okay, well, getting 1 would be horrible, but what I can do quite easily is if I cube that, I will then find that my power on the top there is 2/3 times 3, which just equals 5 squared, which we should know equals 25. Now, so we know that 5 to the 2/3 cubed equals 25. Again, we can take the cube root, and we get 5 to the 2/3 equals the cube root of 25. Again, we don't know what the cube root of 25 is. It'll be about 2.9-ish, but you'd probably just leave it as the cube root of 25. Okay, so the general rule, if you have a to the power of m over n, that equals the nth root of a to the m. You can try it out if you want. And in fact, yes, try it out. Here are some examples. So, work out the value of 8 to the third. Let's go 81 to the 3/4. If you're unsure of how to do this, do use a calculator. I'm giving you numbers that will give you whole numbers as an answer just to make life easier. And finally, work out, let's see, 25 to the 3/2. Doesn't matter that it's an improper fraction, you treat it exactly the same way. So it's going to be the square root of 25 cubed. The best thing about this rule, by the way, whilst you're working that out, is you can do the nth root of a to the m, so you can do it like that, or if it's easier, you can do it like that, so you can work out either the power or the root first. For example, this last one, which I'm now going to give you the answer to, 25 to the 3/2. I don't particularly fancy working out 25 cubed if I had to do it in my head. 25 cubed and then square rooting that. I'd much rather square root 25 and then cube that. Obviously, the square root of 25 is 5, so the whole thing is just 5 cubed, which equals 125. 8 to the 1/3 is just the cube root of 8, which is 2. And 81 to the 3/4. Well, the fourth root of 81 is 3, so it's 3 cubed, which equals 27. So I hope you enjoyed this video. My next video will probably be on surds, although at some point I will also make a video on how to do all of this stuff on your calculator in case some of you aren't sure. In the meantime, do go and find another video or someone to explain it to you. But until then, look after yourselves.